Math 1314, Tyler Junior College, section 2.4, more about slope. Interpreting slope as a rate of change. Anytime you have a word problem or a context, a real world situation, when you're talking about slopes or lines, the slope can be interpreted as a rate of change, meaning how much something is changing relative to something else. Now, you know the concept of rate of change. If you've ever driven a car and you're driving along and you see a cop on the side of the road and you slow down, why? Because you were probably going over the speed limit. So for example, if the speed limit were 35 miles per hour, but you were going 41 miles per hour, you probably slowed down. Both 35 miles per hour and 41 miles per hour are called rates of change. They are measuring how much one thing changes compared to another. For example, 35 miles per hour means that as long as your speed is consistent, you will increase your distance 35 miles per 1 hour that you drive. Well, any slope can be interpreted the same. For example, in the year 2000, about 15.5 million women aged 18 or over lived alone. These are U.S. Census Bureau numbers. I didn't just make them up. In the year 2013, this number increased to 18.6 million. Assuming a linear graph, calculate and interpret the slope. You see I've already got a rough sketch of the graph drawn. We're interpreting the x to mean the year. So let's actually write x equals year. And we're assuming the y to be the women in millions. It's common to use smaller numbers and just make the unit of measurement something large so that we don't have to write something like 15, 500, 500. So let's calculate the slope, which is easy, and then interpret it, which is actually also easy. By now you should know the formula for slope. Difference in y's over the difference in x's. Well, I don't have my points labeled yet, so let's go ahead and do that. The first ordered pair, according to this graph, is 2000, 15.5, and the second ordered pair is 2013, 18.6. So if we subtract the second y, 18.6, minus the first y, 15.5, and then in the denominator, the second x, 2013, minus the first x, 2000, we will get 3.1 on the top and 13 on the bottom. And if we divide that out, let's see what we get. I think it's about 0.24. Yes. Now, why would I divide it out instead of leave it as a fraction? Well, first off, leaving decimals and fractions is considered bad form. Either make it a fraction or a decimal, but not a combination of the two. But for interpretation purposes, the decimal will be much more convenient. If we divide this, we get about 0.24. By the way, if you wanted to keep this a fraction but remove the decimal, you could multiply both sides by 10. That would cause the decimal to move to the right one place on the top, making it a 31, and making the bottom 130. But again, for interpretation purposes, decimals are usually more convenient than fractions. So we'll divide this and call it 0.24. But 0.24 what? Well, think about the genesis of slope. The top number of a slope represents a rise, and the bottom number represents the run. So what this fraction means before we divided it was, if the x increases by 13, we predict the y to increase by 3.1. Or, using what they're measuring, if 13 years elapse, we expect the number of millions of women who live alone to increase by 3.1 million. That sounds weird, but if we translate it to a decimal, we can kind of interpret it the same way, and it makes a little bit more sense. Now you might be wondering, how can we interpret this decimal as rise over run? We just turned it out of a fraction into a decimal. Well, if we think about it as a fraction over 1, for the sake of having a rise and a run, let's think about what each of these are measuring. The rise is measuring the change in the y's, which is millions of women. So 0.24 million women. And the denominator of this, now it's a fraction, is 1. That means 1 year, since the run is measuring the change in the x's. It's like saying, and this is not drawn to scale, if we moved over 1 year, how much would the number of million increase or rise? In this case, 0.24. So if we wanted to interpret this in context as a rate of change, we could say the following. The number of women who live alone increases because the slope is positive about, because we rounded, 0.24 million per year. Rate of change. Millions of women per year, miles per hour, miles per gallon if you're measuring your car's efficiency. But anything that compares one number to another is called a rate of change, and usually the second number is in terms of 1 unit, in this case 1 year. So it's really pretty easy to interpret a slope in the context of a problem. You simply say whatever your y variable is measuring, so this is what y measures. The number of women who live alone increases if positive, increases if slope is positive, and of course decreases, it says decreases, believe it or not, if slope is negative. Here you put your slope, but for a reason which I'll mention in a moment, this number is always positive, even if your slope is negative. The number that follows the slope is the y unit of measurement. What was your y measuring? Millions. Millions of women, to be specific. And whatever goes after the word per is your x unit of measure. In this case, x was measuring years. So you can actually build a template for interpreting a slope. Whatever my y is measuring increases or decreases depending if the slope is positive or negative about, say the slope, but say positive, say the unit of measurement for the y per unit of measurement for the x. For example, let's say that we were doing something like this, but we were calculating how much your salary changed per month. So let's say that in month 1, your monthly salary was $3,000, and in month 4, your salary went down to $2,700, maybe because you had a signing bonus or something. That slowly deteriorated over 3 or 4 months. If we calculated the slope, the second y minus the first y is negative 300. The second x minus the first x is 3. Negative 300 divided by 3 is negative 100. Keep it in mind that the x is measuring months, or you could say years, but that would be a pretty sorry yearly salary. And y equals monthly salary. Then how would we interpret this? We would say monthly salary, because that's what the y is measuring, decreases, because the slope is negative, about, although in this case it's exact, 100. Monthly salary is measured in dollars per whatever the x is measuring, month. So pretty cut and dry. What's my y measuring? Is my slope increasing or decreasing? What is my slope positively? unit of measurement for the y per unit of measurement for the x. The reason that I don't say negative 100 is because I said decreasing. Decreases implies it's going down. If something decreases in negative, it actually goes up. That sounds weird, but it's correct. All right, so interpreting slope as a rate of change, pretty cut and dry.